Welcome to my channel. This is the second video of tangent normal. In my first video, there was the theory of tangent normal, and now today, and there is some problem also, important 4 and 5 problem I think. And now today, I introduce some problem, and see that there are numbering and the different, and this is the problem of the book of S.N.Dey. Okay, students, see carefully. This is the book of S.N.Dey, and there was some notation, marking notation, marks 2, marks 4, and marks 5, like that. Okay, so follow the question number first 24 here. So here the question: these two curves, these and these, intersect orthogonally, then so that 1 by A and minus 1 by B, that is equal to 1 by C minus 1 by D. Okay. Sorry. So what is the meaning of the curve orthogonally, students? That means the two curves, where they intersect at that point, the two in between the two tangents angle make an angle 90 degree. That's why when the two curves are cut orthogonally, it means they cut 90 degree, make an angle, tangent and make an angle 90 degree. Okay, see. So see, here is the one of the ellipse, and this is another ellipse. So let us see. Here is a x square and b y square. This is the b y square, and that is the 24. And this is the question number marks 4. Okay, this is the book of S.N.Dey. Okay, there also this marking was there. Okay, is there ax square by square equal to 1 and cx square plus dy square equal to 1. See, they intersect at that point, and like this is a tangent at that, and also this is another tangent of this curve, and this angle is 90 degree. It means they cut orthogonally. Okay, so that's why let us assume at that point P x1 comma y1. So differentiate this and this at that point. Okay, what happened here? See, 2ax and 2by and dy dx. Okay, and again 2by dy dx equal to minus twice ax. So again write dy dx, and that is equal to ax by by. So dy dx at the point which mentioned here, I have mentioned here x1 comma y1. Okay, and you can write here minus ax1 by by1. So this is the slope of the first tangent to the curve. Let us assume this is the equation of the ellipse. And for the second curve, we can easily, same figure is looking same as, so we can easily write m2 is equal to, that is dy and dx for the second curve. For the second curve, that is x1 and x2, x1 y1, and that is equal to, we can write here a b b x x y y, same pattern. So that's why we can write c x1 by d y1 here. Okay, and angle between them is 90 degrees, so we can write the angle between two tangent, that is m1 m2 is equal to minus 1. So now therefore minus ax1 by b y1, another is minus cx1 and d y1 is equal to minus 1, implies that. So that is ac by bd, x1 square by y1 square equal to minus 1. So now, so we can find x1 square is equal to minus y1 square, that is bd by AC. This is number 1. And again these two curves are passing through the point x1, y1. The curves, the passing through the points, that is x1, y1. So we can write here that is ax1 by1 square is equal to 1. Another cx1 square, this is this is d here, dy1 equal to 1. So subtract these two, then we get here x1 square and a minus c and y1 square, and this is minus d, so equal to 0 from this two number. Okay, from 1 and 2. So we can write here from 1 and 2. So that is put x1 of this figure to this equation. Okay, so that's why a minus c into x1. This is here x1, and we can say that in place of x1 we replace this, and somewhere says that this is a value, not value. We replace as this. Okay, this is subject to the y1. Okay, and this is ac, and this is plus y1 square into b minus d equal to 0. Okay, now take a common y1 square and cancel these points. Okay, now we get here this is as a minus c into bd by ac plus b minus d equal to 0. And therefore y1 never is 0, so that's why this equal to 0 here. So implies that we can write a minus c by ac into bd, okay, and this equal to b minus d here, and implies that a by ac, c by ac is equal to this bd on the left hand side, and it is in the product form, so this part are divided by b minus d. Okay, b minus d by bd, and can be written b by bd and d by bd. So again write here that is 1 by c minus 1 by a is equal to, this is 1 minus d. So this is 1 minus d and 1 minus b here. Okay, we have to, so 1 by a minus 1 by b. So this 1 by a transferred to the left hand side, and d is transferred to the left hand side. Okay, 1 by d here and 1 by a are shifted to the right hand side. Then you got the answer. Okay, see, here is the right equal to left and it is left equal to right. Okay, see, it's proved. Okay, very important question, an interesting question for these classes. Okay, these classes. Okay, now see, now I want to introduce the question number 16. Okay, see carefully. Next question is 16. See that the line x cos alpha plus y sin alpha equal to p touches the curve. It means this is the tangent to this curve. Then so that this. Okay. Main logic is this is the tangent. So we have to find the tangent to a point like x1, y1. Then after both the equation are identical, then we can from that we show this the condition. Okay, see, this is the question here 16. So again read that this is touch this curve, so this is the tangent to this curve, then so that is this. Okay, now x cos alpha and y sin alpha is equal to p. This is 1. Now for the curve, that is x to the power m, y to the power n, and that is equal to a to the power m plus 1. For finding the derivative, okay, finding the derivative of this curve, we take a logarithm of this, then differentiate would be easy, okay. So m into taking log on both sides. So this plus n into log y, and that is m plus n into log a, okay. This is to the base e order, okay. Now differentiate both sides with respect to x, then we got m by x plus n by y, and this is here dy by dx, and this is 0 here. So dy by dx is equal to minus m by x, and this is here, so this is y by n. So you can write m by n into y by x here. So therefore the slope of the tangent at x1 comma y1 is m1 equal to dy dx, and that is x1 comma y1. This is equal to m by n and y1 by x1. Okay, therefore the equation of the tangent at x1 comma y1 is y minus y1 is equal to minus my1 by n x1 and x minus x1 here. So now this is here n into x1 y minus here this is m into y1 into x, and this is equal to, we can write like take a common here x1 m1 x1 y1. If we multiply this here plus m, and also on the right hand side, and that is minus n into x1 y1, okay, n into x1, take a common x1 y1, this is here m, this is here 2. So 1 and 2 are identical, 1 and 2 are identical. Why these two curves are identical? And it is given that this is a tangent, and we have to find, we just find this equation of the tangent at the point x1 y1. If the two lines are same, means identical, then we can compare with this ratio. And here is the coefficient, and there is the coefficient of x and coefficient of this x and their ratio, coefficient of y and this coefficient of y and their ratio are always equal and also constant. So what is the type of writing this my1 by, this is the coefficient of x, and here is cos alpha. Okay, same as the coefficient of y here is n x1, and this is where, and sin alpha. Again x1 y1 m plus n and by p here. Okay, this is the right, and this is the third. If we take this equal to this, then we get here, so y1 and y1 cancel, so we got here x1. So x1 is equal to, you can write mp, this is the mp by cos alpha into 1 by m plus n. Again, see y1 or y1 cancel, then we find the x1. So this we are multiply here pm by cos alpha, and this m plus n are divided by this. Okay. So again, same as y1 also be written like yx1 are cancelled, so y1, that is np by cos alpha, and also this is here m plus n. Okay, these two values of x1 and y1 are satisfy the curve. The curve is this. Okay, Now the point. Now the point x1 comma y1 lies on the curve x to the power m, y to the power n, and a to the power m plus n. Okay, then you can write x1 to the power m and y1 to the power n is this. So this is 4 and this is 5 and this is 6. Then from 4, 5 and 6. Okay. So put the value of x1 is here. So that is m into p by cos alpha, that is m plus n, and whole to the power m here. And same as y1, this is np by cos alpha, this is m plus n to the power n here, and that is equal to the power m plus n. Now I can rewrite here, that is m to the power n, same as n to the power n. Okay, see here, m to the power n and a to the power n. Okay, and here is p to the power m and also p to the power n here. And by numerator part is here cos alpha to the power m here, and both are cos. Okay, I am wrongly written here. This is sine, or this is a sine. So this is a sine. I am wrongly written here. So sorry. And now here is y. So this is a sine. Okay. Okay. So cos alpha to the power m, and this is sine alpha to the power n. This is a sine alpha to the power n, and m plus n to the power m, and this whole to the power n equal to a to the power m plus n, and it's complete. So see again, we write here m to the power m to the power n, p or p, both p are m plus n power, and that would be a to the power m plus n into cos alpha to the power n, sin alpha to the power n. Okay, and m plus n, both the ways are same, so power be added. Okay, see carefully, the 16 number solution is the best important solution for these two problems, 24 and 16, and like that. Okay, this type of pattern problem are related with the board exam with HS and ISC, and also the competitive exam like joint IIT and more of the others exam. Okay, see carefully. Okay, so now follow the next question, that is 5 marks 15 here. Okay, see. So the same problem, that is the logic. It is given that the Lx plus My equal to 1 is a tangent, and this touches the curve, this means tangent. So we find another tangent at the point x1, y1, then find the logic is this here. Okay, same problem. So now in my first video to the theory of the classes of the tangent normal, there was some discussion like we can easily find a tangent, that is if we given that the curve is this is, then what is the tangent, that is x by a square and y by b square, and replace by x1 or y1, then you can easily find the tangent here. Okay, so this pattern I want to introduce here. Okay, see for the question number 5. 15, sorry, 15, okay. So this is the tangent Lx plus my is equal to 1, okay, number 1. And now for the curve a to the power n, that is given that the curve here is ax to the power n and by to the power n here equal to 1. And now a to the power n and x to the power n plus b to the power n and y to the power n equal to 1. From that, so that is a to the power n xn to the power n minus 1 into x, same as, see, if we added these two powers then we got this, okay. And you know, if we find a line, so the degree of x and y is 1, so this is as a variable, we can replace x1 and y1 in place of that. So this is the tangent, okay. So 1 and 2 are identical, so this is the tangent. This is the tangent at x1, y1, okay. So this is the easiest technique to find the tangent for the competitive exam, but for the board exam need to be proceed the previous question like 24 and 16. There was the procedure we have introduced how can find the equation for tangent, okay. So now 1 and 2 are identical when 1 and 2 are identical. Then, so see, the coefficient here is of x is a to the power n and x1 to the power n minus 1, and again here is n, and the coefficient of y is b to the power n and y1 to the power n minus 1 by m, and again okay, this is 1 by 1, okay, this is here 3. From this, if we take this equal to this, so now find x1. So we have x1 to the power n minus 1, and that is L by a to the power n here. Okay. Now I want to find like ax to the power n here, but here look, x1 to the power. This technique is very important technique. See carefully. So degree of x1 is here. Only the problem here is x1 and y1. So these two variables like x1 and y1, I want to eliminate it. So eliminate. So like here x1. So to the power n minus 1. See, I want to product of ax to the power n, but ax, I need to want ax. So that's why a to the power n minus 1 multiplied by on both sides. So a to the power n minus 1, there is l, and a to the power n here. And if we simplify these two, then we get here L by A. Okay, L by A. Okay. So now implies that this x1 and a whole to the power n minus 1, L by A. So simply follow x1 a, and this equal to L by A to the power 1 by n minus 1, and also x1 a and to the power, and this power be n here. See, this power be n. So that's why n, and L by a and to the power n by n minus 1. Okay, see, this is 4 here. Okay, and similarly we can find from this, that is b to the power n and y1 to the power n minus 1 is equal to m. So by b to the power n. So same as multiply by b to the power n minus 1 and y1 to the power n minus 1. So n m by b to the power n into b to the power n minus 1. So m by b here. Now both the power are same, so we can write here b y1 to the power n minus 1 equal to m by b here. So implies that b y1, and that is equal to m by b whole to the power 1 by n minus 1. So b y1 to the power n, that is m by b whole to the power n by n minus 1. So this is question number 5. So add 4 and 5. adding 4 and 5. Then x1 n plus y1 b to the power n, and this value is this. So we got here L by a to the power n by n minus 1 plus m by b to the power n minus 1. Okay, see this equal to 1. See this is equal to 1 since a x1 to the power n plus b y1 to the power n is equal to 1. Okay, so it's proved. Okay, very important question. So now next point is here 14 marks 4. Okay, see. Question here is, if the tangent to the curve y equal to x cube plus ax plus b at 1 comma minus 6 is parallel to the line is this. Okay, x minus y plus 5 equal to 0. Find the value of a and b. So at the point 1 comma minus 6 of the curve. So number 14, as 1 comma minus 6 lies on the curve y is equal to x cube plus ax plus b, then we can satisfy this. In place of y is minus 6 and 1 cube a into 1 plus b. So therefore a plus b is equal to minus 7. This is the equation number 1. And differentiate is this curve at that point is called the slope. Okay, y is equal to y I want to differentiate is this here, as this is parallel to this line. It means tangent is parallel to this line. So it means if we differentiate this curve at the point 1 comma minus 6 is called the slope, and of this line are parallel, so we find the slope of this line also, then equate this equation, so and we find another equation of a and b. So see here, y equal to x cube plus ax plus b, then differentiate, we get here this at the point di by dx, that is 1 comma minus 6. If we put, this is in place of x, put here 1. So we got here this, and this is 2. As the tangent is parallel, as the tangent is parallel to x minus y plus 5 equal to 0, so m equal to slope, this is 1. So from these two slopes are equal. So therefore from 2 and 3 we get here 1 equal to 3 plus a. So a equal to minus 2. And now a plus b is equal to 7. Put the value of a here is minus 2. Then we got here. Got the value. This is here minus 7. And this is here minus 7. This is b. This is minus 7. So b is equal to 2 minus 7. That is minus 5. Okay. This is the value of a. And this is the value of ba. Sorry. Now we want to solve the problem number 9 of marks 4. Find the equation of the tangent and normal to this curve, where these curves meet at the point with the x-axis. You know, the equation of x-axis be here y equal to 0. If we put there, then we got the value here is x equal to 7. So point of intersection where the curve intersect at the x-axis, that is 7, 0. Okay, so at that point we have to find the equation of tangent and normal. Okay, see. So this is 9. So y into x minus 2 and x minus 3 plus 7 equal to x. This curve intersect with x-axis. So y equal to 0. Put here 0 into x minus 2, x minus 3 plus 7 equal to x. Therefore, we got here x equal to 7. Therefore, the intersecting point is 7, 0. Now we have to find the slope at that point to this curve. What they touch at the point 7, 0. So find the slope of the normal and tangent at that point. Okay. Now differentiate, and that is x minus 2, and this is x minus 3. This is x minus 3. Okay, see, this is your curve plus 7 equal to x. So technique of differentiation, see here. So, okay, this is your 1. So, x minus 3, if we differentiate, is this. And again, x minus 2, x minus 3, and here, derivative of y is this. And derivative of y, 7 is 0, and x is this 1. So now putting the value of 7, 0. So at 7, 0. At 7, 0. This is here the value of y is 0. So that is 7 minus 2. Same as this is also 0. That is 7 minus 3. And here 7 minus 2. Okay. And 7 minus 3. And also dy by dx also mention that 7, 0. That is 1. Okay, that is 1. Now this is 0. So we have to on this. This is 5 into this is 4 here, and this is dy by dx. Okay, is 1. So slope m1 is dy by dx at 7, 0 is equal to 1 by 20. Therefore, slope of tangent is m1 equal to 1 by 20, and slope of normal is m2 equal to plus 20. Therefore, the equation of the tangent at 7, 0 is y minus 0 is equal to, this is 1 by 20, and x minus 7. So implies that x minus 7 is equal to 20y. Okay, x minus 7 is equal to 20y, and that would be x minus 20y and equal to 7. Okay, and now see the next question. And now find the equation of the normal. Therefore, the equation of the normal at 7, 0 is y minus 0. That is minus 20. Slope is for normal is minus 20, and x minus 7. That is here y plus 20x, and this is here plus 140. Okay, This is the tangent and this is the normal. Okay, see carefully. And now we have to solve the question number 25 for marks 2. This is 25. See, very easy question. Let's see. Find the equation of the normal. That is given. That is x equal to a 2 cos t plus cos 2t, and also y equal to a into 2 sin t minus sin. This is 2t. Okay. At t equal to pi by 2. So we have to find the value at and t is equal to pi by 2. Okay. The next one is equal to what? If we put here pi by 2, then this is 0 and this also cos pi, and cos pi here is minus 1. Okay, and this is minus a. Again y1, a into 2 sin pi by 2, and this is sin pi. So here is 2a. So it is minus. Okay. So therefore the points where the normal are formed. Therefore the points is there minus a comma 2a. Okay. Now find dx dt. That is a minus 2 sin t minus 2 sin 2t. So dx dt at minus a comma 2a. This is here. This is here. Can t is equal to pi by 2 here. If we put here pi by 2, this is minus 2 into 1, and this is here pi. That's why it's 0. So minus twice a. And again find the derivative dy dt. Okay, that is a into 2 cos t minus 2 cos 2t, and this is here dy dt at t equal to pi by 2. A into 2 cos pi by 2 minus 2 cos pi is 0. This is minus 1. That is twice a. Okay, minus plus plus or twice a. So therefore dy and dx is equal to dy dt by dx dt here. So this is dy dt, this is twice a, and this is minus twice a, and that is minus 1. So therefore the equation, this is the slope of normal, this is the slope of tangent. So we have to find the equation of tangent and normal. Okay, therefore the slope of normal is m is equal to plus 1. So that was the equation of the tangent is y minus y1. That is here this twice a. This is minus 1 into x minus a. Okay, this is plus a. Now see, y plus x. This is 2a. This is minus a. That is a. So y plus x is equal to a. Therefore the equation of normal is y minus twice a. This is here plus 1 into, okay, y minus x, and this is here twice a. Okay, see carefully. This is the another problem of tangent normal is this. Okay. Now next point, Okay. Okay, clear. Now 22. Now this is the 22. See, the equation of the normal to the curve at the point D. So we have to find the slope of the tangent 3a xy. So differentiate this 3x square, 3y square, and dy by dx. This is 3a x into dy by dx plus y into x is 1. Put the value. So add 3a by 2 comma 3a by 2. This is 3a by 2, 3a by 2. Okay, see, put the value of x in place of x is 3a by 2 and you also y 3a by 2. So 3 into 9 a square by 4. So 3 into 9 a square by 4 dy by dx. 3a by 2 into dy by dx plus 3a by 2. Okay, so see, again there is a question that is 3, 3. So 3, 3 and 3 are cancelled. So 9 a square by 4. 9 a square by 4. This is dy by dx. This is 3 a square by 2 dy by dx. This is 3 a square by 2. Now see, we have take a common is dy by dx, and that is 3 a square by 2 minus 9 a square by 4. And this also shifted to this, and this here 3 a square by 4 minus 3 a square by 2. So therefore dy by dx at 3a by 2 comma 3a by 2 is this. If we take a LCM, 3a square by 2, 3a square by 2, 9a square by 2, both are same but alternate, so you get here minus 1. Okay, so therefore the equation of the normal, so slope of normal is m1 is equal to plus 1. If sign be negative, then normal sign be positive. Okay, equation of normal is y minus 3a by 2 is equal to 1 into x minus 3a by 2 here. This is 3a by 2. So y equal to x is the equation of the normal. Okay, and now for the 6 and 4. So see, both are very easy question. See again, we have done the question number 4. So find where the tangent are parallel. So here y is equal to x square, differentiate at x1 y1, where the parallel at the point x1 y1, that is twice x1. Okay, and now y is equal to 4x minus 5. If we differentiate, then we get here this is 4. Okay, so this is parallel to this line, tangent is parallel to this line, so we can take this equal to this. Okay, so twice x1 is equal to 4, so x1 is equal to 2, and the point lies on the curve. Okay, so therefore y1 is equal to, this is 2 square, this is 4, therefore the point that is 2, 4, and this is the answer where the tangent is parallel to the line y equal to 4x minus 5. And number 6 here, see, this is 4 here, and number 6, find the equation of the tangent to the ellipse at 4, 3 here. So 9x square, this is 16y square, 0, 2, okay, 288, but I think it's the wrong date. I don't know the date. Okay, like 18, this is x, This is 16y and dy by dx and equal to 0. So dy by dx at 4 comma 3, and that is equal to minus 18 into x is 4 by 16 into y. 16 into y means 3. So 4 4 therefore, and this is a 2 and 9, and this is 3 and 3. This is minus 3 by 2. Okay, so you have to find the equation of the tangent. Okay, therefore the equation of the tangent to the curve. And 9 36 16 okay, only that. So y minus y1 is 3 here, and the slope here is minus 3 by 2, and this is x minus 4. Okay. Actually this point should be satisfied this curve, but I think these two agents are wrongly written. So let's see if we find satisfy this equation or not. Okay, this is a very good classes for the tangent normal. See carefully. Okay, we have to introduce some problem on the next video for the tangent normal. Okay, bye.